Okay, so today is October 27th, 2014. Our topic is we're going to revisit ratios and rates, but we're going to focus on qualitative reasoning, using ratios and rates to compare and predict outcomes. The essential question that you will need to be able to answer at the end of the video is, what is qualitative reasoning? Let's start off with some definitions. These are words that you're going to have to know the definition of and know what they mean in order to understand the next part of our notes and what we're going to be working on. So the first definition is compare. This is a word that you should be very familiar with. Compare simply means to estimate or show a similarity or differences between two quantities when you compare something. Then you have prediction. Prediction is to have an idea of what will or could happen based on given information. So basically, to make a prediction, you're just looking at the information that you're given, and then you're saying, okay, the answer could be this because of the information that you were given. Ratios, something we've already spoke about as well. It's a multiplicative comparison of two quantities. For example, there are 3 blue squares to 1 yellow square. If we were to double that quantity, that means multiply both the blue and the yellow by 2, then we would have 6 blue squares to 2 yellow squares. That's where the multiplicative or multiply part of the comparison comes from. Then we have rate. Rate is also a ratio, but it compares two different quantities where the measuring unit is different for each quantity. So for example, when we're talking about rates, you're usually talking about, for example, 60 miles in 4 hours, 3 cakes in 1 minute, anything that's compared to a unit of measurement. And then we have qualitative reasoning. Here I actually give you the definition. And the definition is a broad description without using numbers. Broad means a very wide or open description. For example, the speed of car A is slower than the speed of car B. It's not giving you an exact number of how slow it is, but it is giving you a general or broad description that car A is slower than the speed of car B. So that's what we're going to be working on in our notes, is finding the qualitative reasoning for different ratios and rates. Again, keep that in mind. It's a broad description, a general description, not anything using numbers. Here we have qualitative reasoning to compare ratios and rates. First, let's look at ratios. Again, it's a general description. So when you're comparing qualitative reasoning for ratios, you'll see things like color is brighter, taste is sweeter, pace is slower. You don't see any specific numbers. So let's look at our example problem. Jane made lemonade using 2 cups of sugar to every 2 cups of water. Sarah made lemonade using 4 cups of sugar for every 2 cups of water. Who made the sweetest lemonade? Well, let's look at Jane's ratio. Jane's ratio is 2 cups of sugar for every 2 cups of water. So when we simplify that, you would divide 2 divided by 2 and you get 1 to 1. So her simplified ratio is for every 1 cup of water, Jane adds just 1 cup of sugar. Let's look at Sarah's ratio. Sarah has 4 cups of sugar for every 2 cups of water. Again, when we simplify that ratio, we get 2 cups of sugar to 1 cup of water. So for every 1 cup of water, Sarah adds 2 cups of sugar. So based on this information that we're given, we can say that Sarah's lemonade is sweeter than Jane's lemonade, or Jane's lemonade is less sweet than Sarah's lemonade. Please see that our answer does not have any numbers. We didn't say anything specific. We gave a general description of the comparison of Jane's lemonade to Sarah's lemonade, saying that Sarah's is sweeter than Jane's. Here we're talking about rates. When we're giving a general description of the comparison of rates, you say something like decreases faster, or more per pound, or earns more than. So let's look at the example problem here. Joe earned $40 in 4 hours. Jacob earned $40 in 2 hours. Who earns the most money? Let's look at Joe's ratio. $40 in 4 hours, when simplified, will give us Joe's amount per hour, which is $10. Here we have Jacob's $40 in 2 hours, and when simplified, we have for every 1 hour, Jacob earns $20. To give a qualitative answer, we would say Jacob earns more than Joe, or Joe earns less than Jacob. Again, I did not give a specific number. I gave a general description. Jacob earns more than Joe, or Joe earns less than Jacob. A very general answer. Here is one practice problem that you will have to do for qualitative reasoning for comparing ratios and rates. Please write the question and then answer. It is only one practice problem that you have to do. Please write the question and then answer. Let's go on to making predictions. So we're going to use qualitative reasoning again, very general description, broad description as our answer, to make predictions involving ratios and rates. So let's look at our example problem. Car A drives 40 miles in 4 hours. If car B is slower than car A, but faster than car C, what could be the distance car B and car C would travel in 4 hours? That's a very long word problem, so let's break it down. Well, first let's look at the ratio for car A. Car A goes 400 miles in 4 hours, when simplified to 100 miles in 1 hour. Then the problem says car B is slower than car A. So what could we predict about the amount of miles it travels in the same amount of time, which is 4 hours? Well, if it takes car A 4 hours to travel 400 miles, then that means it will take car B more, since it's slower than car A. So let's say it would take car B 5 hours. So then we have 400 miles, the same distance, in 5 hours. Here we have 400 over 5, which simplifies to 80 in 1 hour. So the same amount of time, 1 hour, car B travels only 80 miles, or less, in 1 hour. So that shows us here that car B is slower than car A. And then the problem goes on to say car B is faster than car C. So car C will take longer than car B. So let's say it takes like 8 hours. So 400 miles in 8 hours simplifies to 50 miles in 1 hour. So car C travels 50 miles or less in 1 hour. So here when we're making predictions, we are using a few numbers, but it's still very broad because it could be car B could travel 80 miles, 75 miles, 70 miles, 62.3 miles. It could be really any number as long as it's less than 100 or less than car A. That goes for car C as well. As long as it's less than car B, then it could be any number for car C. So again, a very general, broad description. Let's try another example problem. Here we have apples cost $5 for a 5-pound bag. If apples cost more per pound than peaches, but less per pound than oranges, what could be the price per pound for peaches and for oranges? So again, we need to break this down because that was a lot of words and very long and lengthy word problem. So let's break it down. Here we have apples. Well, it says $5 per pound. So when we break this down or simplify the ratio, we get $1 for every 1 pound of apples. Then it says apples cost more per pound than peaches. So if they cost more than if apples cost more than peaches, then that means it has to be less than $5 per pound. So let's say $4 per pound. So if it's $4 for every 5 pounds, that simplifies, or we can convert the ratio to a decimal, which is 80 hundredths. So we could say peaches cost 80 cents or less per pound. Again, general description, as long as it's less than $1 per pound, it falls within the guidelines. And then it says apples cost less per pound than oranges. So if apples cost $1 per pound, then the price of oranges will be more than $5 per pound, like $6 per pound. So here's our ratio, $6 for every 5 pounds. And if we simplify that, we get 1 and 20 hundredths. Since we're talking about money, oranges could be $1.20 or more per pound. Again, the general description is that oranges have to be more than $1 per pound so that it falls within the guidelines of costing more than apples. Here's your second practice problem. Please make sure that we write our question and then we answer. So here you're making a prediction of how many people could possibly ride the rides. I understand it was a lot of information. Please go back and reread, re-listen, and make sure that we're taking very good quality notes.